Hello students, let us go into the question number 2.3 example problem in your book. The question is, a copper wire of cross-sectional area 0.5 millimeter square carries a current of 0.2 amps. If the free electron density of copper is 8.4 into 10 to the power 28 per meter cube, then compute the drift velocity of the free electrons. So this is your question. Understand the question first and write whatever they have given there. So what are the things they have given? It is the cross-sectional area A, which is 0.5 millimeter square. See, area is one parameter into another parameter, that is length into breadth or side into side. So how did we get this millimeter square is one, say for example, if it is length into breadth, length is millimeter and breadth is in millimeter. If you multiply this, it becomes millimeter square, right? So to convert this one term from millimeter to meter, you have to add up 10 to the power minus 3. And for the other term, another one 10 to the power minus 3. So to convert the area from millimeter to meter as it is the SI unit, you have to convert it by adding 2 10 to the power minus 3 there. So, area A equal to 0.5 into 10 to the power minus 3 into 10 to the power minus 3 meter square. Add up the powers, it becomes 0.5 into 10 to the power minus 6 meter square. This is area. Then, it carries a current of 0.2 amps which is given. Right? So, the current I is equal to 0.2 amps. If the free electron density of the copper is 8.4 into 10 to the power 28 per meter cube, the current density, electron density is given. Electron density is nothing but the number of electrons per unit area, right? So, number of electrons N is equal to 8.4 into 10 to the power 28 per meter cube. And one more term, as if you have the term called electron, you can go for this term which is charge of electron E is equal to 1.6 into 10 to the power minus 19 coulomb, which is known. All these terms are given there. Then what we have to find is, then compute the drift velocity of free electrons is there in the question. So we need to find the drift velocity Vd. Okay. So what are the terms of relating all these terms? What are the formula we know to find the drift velocity? It is Vd equal to I by N E into A. So I value we know, N value we know, E value we know, and the A value we know. Substitute directly all the values here in the formula. Then the drift velocity Vd is equal to, I value is 0.2. So 0.2 divided by N, number of electrons, it is 8.4 into 10 to the power 28 into the charge E is 1.6 into 10 to the power minus 19 into the A value is 0.5 into 10 to the power minus 6. Now have the terms alone and have the 10 powers separately. So 0.2 as such. Multiply all these whole terms. You will be getting 6.72. Then add up the 10 powers. 28 minus 19 minus 6, it becomes 10 to the power 3. Okay. So I am writing this term alone separately and bringing this 10 to the power 3 to the numerator, it becomes 10 to the power minus 3. And now I want to remove the decimal in the denominator. It is 2 digits after. So I have to go for into 100 by 100. If you do that, 0.2 into 100 is, see, 2 into 100 you multiply, and after one digit you have to place the decimal. So it is 20.0, simply 20, right? So it is 20.0 divided by, if you multiply this, you will be removing the decimal, 672 into this 10 to the power minus 3 as such. So when you divide 20 divided by 672, it is simply 20, right? So it is 20 divided by 672 into 10 to the power minus 3. If you divide this, you will get the answer nearly almost approximately equal to 0.03 into this 10 to the power minus 3 as such. So my drift velocity Vd equal to 0.03 into 10 to the power minus 3 meter per second is the SI unit. So we have found the drift velocity now. Is it clear? Yes. Thank you.